often in engineering and science or health or geography or all sorts of things, actually, we're often interested in looking to see whether there might be a relationship between two variables. For example, often taller people are heavier than shorter people. Who would know? But that's what we're going to be looking at here when we're looking at correlation. Is there a possible relationship between two variables? We might think, for example, that there's a relationship between the amount of rainfall that an area gets and the wheat crop that could be taken off that area there. Wheat, bread, get it? Okay. So what we would do is we would take some readings and we'd look and say, well, okay, if there's about 20 centimetres of rain, then the tonnage expected in 10,000 tonnes is about 39, and if there's 30 centimetres of rain, we'd expect, or we got about 49. Okay, so it looks like there is a bit of a relationship within reason. Obviously, if there's so much rain that the wheat plants drown, then you're not going to have a relationship. And similarly, possibly if there's no rain at all, then there might be no wheat. But so between a sort of a range, we can see that probably, and you can think it through in your head, that probably there's going to be a relationship between the rainfall and the wheat crop. And so what we can do is we can put in a line that sort of best fits our data to see if there's some sort of trend. So we'd take a straight line. Now we can use Excel to do this. We can use all sorts of sophisticated statistical techniques to do this. What I'm going to do here is just kind of eyeball it. And I'm going to say, well, I can probably put in a straight line about through here. That is good enough to show the trend, and that we might say that this one is a bit off, a bit out, and this one might be a little bit out as well, this one here. So the line that I've drawn is the line of best fit. Okay, now we're not going to look at actually finding that line. We can use Excel if we want to, but I've just drawn by eye a line that says, okay, there is a trend, and this is what the trend looks like. The more rainfall there is, the more wheat tonnage we can take off it. The relationship might not have been as it was in that diagram. What we need to look for is whether our points cluster in a band running from lower left to upper right. If that's the case, then we say there's a positive correlation. So maybe this is a positive correlation. As X increases, then Y increases. So if the rainfall increases, the wheat tonnage increases. The points might be in a band from upper left to lower right. So we say there is a negative correlation. So if X increases, then Y decreases. And if you look at B, the points are fairly closely clustered about the line that we've put in as the line of best fit. C also has a negative correlation, but it's not so close. It's not such a good relationship that we could draw. If you look at D, there appears to be nowhere that you could draw a line. So probably here, there's probably no correlation. The the line doesn't have to be a straight line. Excel is particularly good. If we look at that one, we might say, well, it looks a bit like maybe a bit of a parabola if I was to join that up. Can I do it carefully? Yeah, it might be part of a parabola, or it might be a graph of some exponential decay. Again, we could do it on Excel, but it's clearly not a straight line that would be the best fit line there. Now, a more scientific way of measuring a relationship, if there is one, is to use this really, really nasty formula. You're not expected to even try and use that formula. Your calculators will do it for you, and we'll have a look in the next class about doing this. But what we need to think here is that if this thing R is equal to 0, then there's no correlation, there's no relationship between the two variables. If R is between 0 and 1, then we've got a positive correlation, and our line would be something like that. If R is between -1 and 0, then our best fit line would be something like that. And if R is close to 1 or close to -1, then we've got a strong relationship. But if R is closer to 0, then the relationship is pretty weak. Another type of seeing if there's a relationship is what we call rank correlation. And it's a situation where you'd look, say, at student A and say that they're first in maths and first in science, and student B is third in maths and sixth in science, and you'd be looking to see there if there's a relationship that you could find based on the rank between them. So you'd need to go through, you'd need to find the bits of the equation, you'd need to find D, this is D, the difference. So in the first case, the difference would be 0. The next difference would be -3, would be 1, it would be -1, 2, and 1. Then we need to square the difference. So the difference would be 3 squared is 9, 1, 1, 4, 1. And then we'd need to put in all of those into the equation. We'd need to add up, so R in this case is going to be 1 minus 6 times, now we've got to add up the D squared columns, so it'd be 9, 10, 11, 12, so it would be 16 divided by, now how many of them are there? There are 6, and 36 minus 1, and would work that out, and that would give us another idea of whether there is a relationship between the maths mark and the science mark of a group of students.